In this tutorial, I'm looking at Leaving Cert Higher Level 2023, Paper 1, Question 6. We're told that f of x is x plus 4, and we're told that g of x is x squared minus 2. And we're asked to find the values of x for which f of x equals g of x. So you simply let the two functions equal to each other, bring everything to one side, factorize and solve your quadratic, and the two answers are x equals 3 or x equals minus 2. In A part 2, they've now plotted those two graphs for us. F of x here is the line, g of x is the curve. And they've marked in they've basically come up with a shape from -1 to 2. And they've asked us to work out the region between the two curves from -1 to 2. So the easier section to get here is the bit at the bottom. The curved bit at the bottom is going to be relatively simple to find. The bit at the bottom refers to the area between the curve g of x and the x-axis. And I know the limits I'm going to use. Well, on the left-hand side, the limit I'm going to use is -1. The first piece of information I'm going to find here is I want to work out what is that point. It's almost at 2, but it's not quite there. I want to figure out where does the curve g of x cross the x-axis. And remember, to figure out where a curve crosses the x-axis, you simply sub in y equals 0. So my function g of x is x squared minus 2. And to work out where it crosses the x-axis, you simply let it equal to 0. So I let x squared minus 2 equal to 0. That's equivalent to subbing in y equals 0. Then I add 2 to both sides, so x squared must be 2. So that, if I get the square root of both sides, I end up with x equals the square root of 2. Now that tells me the coordinates of this point here. So the coordinates of this point are simply the square root of 2, 0. And that is very handy because now I can easily work out the area of the shaded region that is below the x-axis. The shaded region below the x-axis is going to be the integral of g of x. I'm simply going to integrate x squared minus 2. And I know the limits I'm going to use. The limits, well, I want to start at -1 and I want to go as far as the square root of 2. So if I integrate g of x and I go from -1 to the square root of 2, whatever answer that gives me, that is the area of the shaded region below the x-axis. So we need to integrate g of x dx from root 2 to -1. The integral of x squared minus 2 is x cubed over 3 minus 2x. And then all we need to do is sub in the upper limit. So here I'm subbing in, instead of an x, I subbed in root 2. So I get root 2 cubed over 3 minus 2 root 2. And then I have to sub in the lower limit. I get -1 to be cubed over 3 minus 2 times -1. And don't forget there's a minus between them. You sub in the upper limit and you sub in the lower limit and you subtract the result from the lower limit from the upper limit. When I subbed in the values for the upper limit into my calculator, I got -4 root 2 over 3. When you sub in the lower limit, you get 5 over 3. So it actually becomes a -5 over 3 with that minus in the middle. And then when I subtract both of them from each other, you get a negative value. You get -5 plus 4 root 2 over 3. However, negative areas don't make sense. And we were expecting to get a negative area anyway, because the area is underneath the x-axis. So it's always going to give you a negative value. So you just ignore the value, you take the positive value. The area is 5 plus 4 root 2 over 3. So despite the fact that you're getting a negative value, that only indicates that it's below the x-axis. But we don't really care about that. So you just take the absolute value of it, or in other words, the positive value. Okay, so now that we know what the area, the bottom of the shaded bit is, we need to work on the top. And the top just poses a little bit of an extra problem. I know exactly what limits I want to use. To get the area of the shaded region above the x-axis, I'm obviously going to integrate f of x. F of x is the straight line, and that if I get the area between the straight line and the x-axis, it's giving me this shaded region. And the limits I'm going to use, I'm going to go from -1 to 2. The only problem with this is if I get the area between the line and the x-axis from -1 to 2, I'm including this little bit, this bottom bit in the corner. So that section there that's been cut off by the curve, that's the problem. I don't want to include that little region there. So what I need to do is I'm going to integrate the line from 2 to -1. And then I'm going to subtract, so I'll integrate that dx, then I'm going to subtract this little section here. So how am I going to get the area of that section there? Well, remember that g of x crosses the x-axis at root 2. And obviously I want to know what is the area from root 2 to 2. So to work out the area of that tiny little section, we are going to integrate g of x again, the curve. Basically we want to know what is the area between the curve and the x-axis from 2 to root 2. So my lower limit will be root 2, my upper limit will be 2. And if I do that, that will give me the area of the little section there. So the area of everything under the line from -1 to 2, but then you subtract this little section there, that gives me the shaded region above the x-axis. If I take this and add on the shaded region below the x-axis, that'll give me my final answer. Okay, so this is probably the trickiest bit, but the integration itself is easy, it's just the substitution that gets messier. So we're going to integrate f of x, the line from 2 to -1, and then subtract that section we don't want. So we're going to integrate the curve from 2 to root 2. So f of x is x plus 4, and the integral of f of x is x squared over 2 plus 4x. And the integral of g of x is x cubed over 3 minus 2x. So then all we do is we sub in the upper limit, which is 2. If you sub in the upper limit, you get 2 squared over 2 plus 4 times 2. And then I put a minus between them and subbed in the lower limit, which is -1. I get -1 squared over 2 plus 4 times -1. And when you simplify each of those down, you get 10 minus -7 over 2. So this bit is what I'm getting from the integral of f of x from 2 to -1. Do something similar on the right hand side. I sub in the upper limit first, so it becomes 2 cubed over 3 minus 2 squared, and then there's a minus in between them, and I sub in the lower limit, which is root 2, so it's root 2 over 3, root 2 cubed over 3 minus 2 root 2. And when you plug that into your calculator, the upper limit gives you -4 over 3, and you get minus 4 root 2 over 3. You have to be very careful with your signs here. Notice that I put everything from f of x into one big bracket and everything from the g of x expression into another big bracket and a minus between them, because I'm trying to subtract g of x from f of x. And then with each one I have the upper limit minus the lower limit. And here it's the upper limit minus the lower limit, but there's an awful lot of signs there and it's very easy to miss one of those minuses. If you plug all of that into your calculator, you get 89 minus 8 root 2 over 6. So that's the area above the x-axis. That's the area of the shaded region above the x-axis. All we have to do now is add up the bit below the x-axis and the bit above the x-axis and get our final answer. So we'll just take the two answers that we've worked out. The area below the x-axis in the shaded region is this. The area of the shaded region above the x-axis is this. You add them together and you get 33 over 2 units squared. Okay, in the final part of this question, we're told that the integral from b to 0 of b e to the bx dx equals e. We're told that b is a positive constant and we're asked to find a value for b. So the content covered here relates to integration 3 on the website. Basically, it's going through how to integrate exponentials. So if you're not 100% sure on this, it's worth looking back at that tutorial. Okay, so let's have a look here. We know that the integral of this is equal to e. So the first thing you should recognize is that b is a positive constant. So when I'm trying to integrate, it doesn't bother me, like it's nothing to do with the integration step. The b that's here at the start, you just copy it down. It's there as well. We didn't really do anything with it, you just copy it down. The thing we're integrating is e to the power of bx. The maths tables tells us that if you have e to the power of something, it stays exactly the same, and then you divide by the derivative of the power. So the derivative of bx is b. So basically e to the bx becomes e to the bx divided by b. So I've integrated now, and now I just need to sub in my limits. My upper limit is b, my lower limit is 0. However, something nice happens here. The b on the bottom and the b on the top cancel, so I actually don't have a fraction anymore. I'm only subbing in to e to the power of bx. If you sub in the upper limit, you get e to the power of b times b. And then when you're subbing in the lower limit, you put a minus between them and it becomes e to the power of b times 0. In other words, the left-hand side simplified now is e to the power of b squared minus e to the power of 0, and that's equal to e as it has been all along. So let's now try and solve this to figure out a value for b. Okay, so I've taken it from where we left off, and remember that e to the power of 0 is simply 1. Anything to the power of 0 is 1, so this becomes minus 1. And then I decided to isolate the term with the b squared in it, so I now have e to the power of b squared equals e plus 1. You kind of hit a dead end now and you might not be sure what to do. But notice that the unknown is in the power. And the thing that we always do when the unknown is in the power is we introduce logs. So I'm going to introduce the natural log here. I'm going to introduce ln. So you put in ln in front of the left hand side and ln in front of the right hand side. Now remember your rules of powers, your rules of logs from page 21 in the maths tables. If you have log of something to a power, you can bring the power in front. So I can write this as b squared ln e equals ln e plus 1. And remember what ln represents. Ln represents log to the base e, which means that ln e is log e to the base e. And if those two numbers are the same, log e to the base e is simply 1. So the left hand side becomes b squared times 1. So I can say that b squared is equal to ln e plus 1. So obviously if we have a value for b squared, in order to get b, we just get the square root of both sides. Now, when you get a square root, there's always two possible answers, but the question said that it's a positive constant, so we're only taking the plus value here. And b works out as the square root of ln e plus 1. Then you can just plug that into your calculator, and your final answer for b is b equals 1.15.